There's a lot of information given in this question, but essentially the diagrams, show us everything we need. And we're trying to model, a three-dimensional bottle, which is pretty cool. So we've got these straight parts, EF and GH, which we can deal with just using cylinders a bit later on. But the focus to begin with is this curve GF. So the student thinks we can use a quadratic. It's going to be a negative quadratic because it's not going like that, it's going the other way. So that's what I'm expecting A to be negative. And then we actually can work out the coordinates of G and F and hence sub them in to find A and B. So let's do that. We can see that the x-coordinate of G is 1 from either diagram, to be honest, but the right-hand one makes it really clear. The left-hand one does as well, because like this is my y-axis, and because the radius is 2, I would just divide it by 1, but it's helping us out. Then we can see from E we're going up by 14 and then another 4, so it's going to be 118. Then F is going to be 4. Again, we just have that 8. That's why this distance is 4, but it's on the diagram, of course. And then this time it's going to be 14. So let's sub in. 18 is equal to A plus B. And I sub in 118. And then 14 is going to be 16A plus B. So I'll do the bottom minus the top to give me 15A equals minus 4. A equals minus 4 over 15. Let me make that really clear that that is a minus. Okay, so as expected, we get this negative. And then if we sub back in, it's just going to be 18 plus 4 over 15, which ends up being 274 over 15. So I've worked out these values. I'm also just going to write down the equation now. So y is equal to minus 4 over 15 x squared plus 274 over 15. We're then asked to use the model to find the volume of water that the bottle can contain. So I'm going to split it into these three parts. I've got volume 1. I've got this is the most awkward volume, 2. And then this volume at the top, volume 3. So volume 1. This isn't too bad. It's already a cylinder, so it's going to be pi times 4 squared times 14. And that ends up being 224 pi. Next, I'm actually going to deal with volume 3. That's going to be pi times 1 squared times the height 10. Gives me 10 pi. That leaves us, like we said, with V2. For this, I'm going to need to do an integration. And I'm going to be integrating along the y-axis. So it will be actually from 14 to 18. And then what we are doing with this more complicated structure is creating a little rectangle. In fact, this is essentially I got dy here and x here to create a little rectangle, and then I'm rotating it around the y-axis. So we'll actually end up with pi x squared dy for this very small cylinder. And then we sum them all up, which is what the integral sign is doing. So I just need to put an x squared dy into here, and then get x squared in terms of y, which we can do. And I'm first of all going to times through by 15. So 15y is equal to 274 minus 4x squared. So then 4x squared will equal 274 minus 15y. And the next squared will just be a quarter of that. What I can do is actually just bring the quarter out. So it will become pi over 4, the integral from 14 to 18, and then 274 minus 15y. I've got into the habit for these of just putting this straight in my calculator, getting the answer. It doesn't say we have to show detailed reasoning. What I would advise is that you do this, but then because it doesn't take very long, just we're using x instead of y, but it doesn't matter. It's the same integral. You can change it to t or u. We'll get the same answer. So do this, get the marks, and then if you have time in the exam, then just like show all the steps. That's my advice. You actually get 136, which ends up being 34 pi. Okay, you could leave a little gap, and then like if you got time, now we'll do it the full way. So then 18. Two, 502. Just press back and change it to 14. 2366. 5 by 4, and we get back to 34 pi. Okay. So obviously that took the longest. So the volume is then going to be the sum of all of these: 224 pi, 10 pi, 34 pi, and it ends up being 268 pi. Doesn't say whether to leave it exact or not. I think we know it's a model. I think I would do both. 841.94 or 842 centimeters cubed. Right, we're asked now to state a limitation of the model, just so that just means something that we've assumed that might not be correct. Divided by 4, and we get back to 34 pi. Okay. So obviously that took the longest. So the volume is then going to be the sum of all of these: 224 pi, 10 pi, 34 pi, and it ends up being 268 pi. Doesn't say whether to leave it exact or not. I think we know it's a model. I think I would do both. 841.94 or 842 centimeters cubed. Right, we're asked now to state a limitation of the model, just so that just means something that we've assumed that might not be correct. So I went with the curve GF, perhaps not being a good fit, which is absolutely fine. I just want to share the other answers that you could have gone with. The measurements may not be accurate. Said about the equation, the bottom of the bottle may not be flat, the thickness may not have been considered, the glass may not be smooth. So yeah, you've got to refer to something like this. I normally go with smooth, but I thought actually the bottle's going to be pretty smooth, but that was still, an accepted limitation. It's not going to be perfectly smooth. The label on the bottle states that the bottle holds approximately 750 centimeters cubed of water. Use this information in your answer to part B to evaluate the model, explaining your reasoning. So there's lots of acceptable answers here. And do you know what? I'm going to go straight for the mark scheme, and I'm going to talk about how I did it. I think I went bigger than I needed to. So yeah, you have to make a comparison and you have to then make a conclusion. Those two things are expected. So you actually can say that, 750 is much smaller, or you can say it's about the same. So they can say it then it is a good model, or it's not a good model. Okay, so just just make sure you're hitting those two things. So I actually kind of went into a bit more detail. I thought, you never buy a bottle of water and it's actually filled right up to the very top. So I thought, like, where would it be filled if it was 750 centimeters cubed? So I worked out the actual V1, the actual value, and it was 703.7. So we're not far off actually. And then I worked out the green volume and halved it. And that actually takes us, okay, it's not going to be perfectly halfway up because it's not um, it's not uniform, but around halfway up takes us to 757 if I do half of the green. So that actually felt like a pretty good, place that the water bottle might be filled up to. So I just, I thought, yeah, this is very close to 750. So actually, it's a very good model. Um, you weren't expected to go into that much detail, but I just want to share how I did it. Okay. Anyway, well done on this question. It's a good one.